November 12, 1928. The air inside Harvard's Mallory Institute of Pathology is thick with the scent of sterilized glass, formaldehyde, and the faint metallic tang of ozone from a nearby electrical apparatus. Outside, a biting New England wind rattles the window panes, but inside this dimly lit, humming laboratory, Dr. Elias Volkoff is oblivious. His world has shrunk to the pinpoint of light passing through the lens of his brass lights microscope. He is a man in his late 30s, an immigrant biochemist who fled the turmoil of post-revolutionary Russia, carrying with him little more than a fierce intellect and a revolutionary idea. For months, he has worked with a relentless, almost monastic devotion, fueled by black coffee and the conviction that he is on the verge of something monumental. His colleagues, the Boston Brahmin Scions of American Science, regard him with a mixture of curiosity and suspicion. They see his foreign accent, his intense, unwavering focus, and his unconventional methods as quirks of an outsider, not the hallmarks of a genius about to decode one of life's most fundamental secrets. Tonight, the final step is complete. Under the microscope, he sees it. A crystalline compound, painstakingly isolated from muscle tissue extract. It's pure, it's stable, and it holds an immense chemical energy within its phosphate bonds. His hands, though steady, tremble slightly as he records the observation in his leather-bound notebook, the one now held in a declassified archival box at the Francis A. Countway Library of Medicine. In neat, Cyrillic-inflected script, he writes, "He has found it. Adenosine triphosphate, ATP. The molecule that powers every muscle contraction, every nerve impulse, every cellular repair in every living thing on Earth. It is a discovery on par with identifying the structure of DNA, a foundational pillar upon which all of modern biology would be built. This single insight explains how a firefly glows, how a heart beats, how a thought forms. It is the secret of vitality itself. This discovery should have been his coronation. It should have secured his place in the scientific pantheon, earned him a Nobel Prize, and transformed his life from one of precarious academic survival to one of celebrated achievement. With his data meticulously compiled and his conclusions irrefutable, Volkoff submits his findings along with a modest grant application to the university's research board. The grant is not for personal gain, but for the resources to explore the staggering implications of his discovery, its role in disease, in aging, in the very mechanics of existence. He waits for weeks, the initial euphoria of discovery slowly giving way to a gnawing anxiety. The response, when it finally arrives, is not a letter of commendation, but a crisp, single-page rejection. The document, also unearthed from the archives, is a masterclass in institutional condescension. It praises the diligence of his work, but ultimately dismisses his application, citing a need for research that aligns more closely with the department's established focus. But it's the coded language, the phrases written between the lines, that deliver the fatal blow. The committee expresses concerns about his unconventional methods, a direct jab at his innovative interdisciplinary approach that blended physics, chemistry, and biology in ways his more dogmatic peers found unsettling. And then, the most damning phrase of all. A note in the margin, initialed by the department head, Dr. Alastair Finch, mentions a concern over his long-term cultural fit within the institution. Cultural fit, a euphemism as cold and sharp as a scalpel. It was not his science that was being judged, it was his otherness. His accent, his background, his refusal to engage in the polite, back-patting politics of the faculty club. He was brilliant, but he was not one of them. The rejection was a wall, built not of scientific critique, but of xenophobia and professional jealousy. The true, devastating impact, however, came 6 weeks later. The spring edition of the Harvard landed on his desk. On the front page was an article by Dr. Finch outlining the foundational principles of a newly identified energy-carrying nucleotide. It was Volkov's work, stripped of its nuance, rephrased in Finch's more palatable prose, and presented as his own breakthrough. Volkov's name appeared only once, buried deep in a footnote acknowledging him for preparatory laboratory assistance. The world applauded Finch. Harvard celebrated its luminary. And Elias Volkov, the man who had discovered life's battery, was effectively erased. His monumental insight had been stolen in plain sight, sanctioned by the very institution that was supposed to champion the pursuit of truth. The system had not just failed him, it had actively consumed his work and cast him aside. How could such a profound insight be so swiftly and completely buried, and by whom? Following that initial, brutal erasure, the question had a clear institutional answer: Harvard and its gatekeeper, Dr. Alastair Finch. But for Elias Volkov, the more pressing question was, a lesser person would have been broken, retreating into bitterness or abandoning science altogether. But Volkov's spirit was forged in revolution and hardship. He was a survivor. Denied recognition, denied resources, he channeled his intellectual fire into an even greater challenge, one that had haunted him since his early medical studies: the chaotic, uncontrolled growth of cancer. If ATP was the currency of life, he reasoned, then cancer was a counterfeiter, a rogue state minting energy for its own destructive ends. He believed that if he could disrupt this illicit economy, he could bankrupt the disease into submission. From 1934 to 1939, using what little money he had saved, he converted the small carriage house behind his rented Cambridge home into a private laboratory. It was a world away from the gleaming, well-funded halls of Harvard. Here, the equipment was secondhand, the chemicals purchased in small, precious quantities. The air smelled of sawdust and solder, a testament to the shelves and racks he built with his own hands. This humble space became a crucible of profound innovation. His theory was as elegant as it was radical for its time. Decades before the field of cancer metabolism would become a mainstream pillar of oncology, Volkov hypothesized that cancer cells, due to their rapid proliferation, were uniquely dependent on specific, high-throughput metabolic pathways for ATP synthesis. They were not just hungry, they were addicted to a particular way of generating energy. He theorized that healthy cells, with their more flexible metabolic systems, could survive a targeted disruption of these pathways, while the cancer cells would starve and die. It was a form of cellular siege warfare. His meticulous lab notebooks from this period, found decades later in a dusty trunk by his grandniece, are a breathtaking record of this pursuit. They are filled not with abstract theories, but with rigorous empirical data. Page after page details his experiments on rodent models, where he induced tumors and then treated them with compounds he synthesized himself, inhibitors designed to block key enzymes in the glycolytic pathway that cancer cells favor. The results, documented in precise charts and stark black and white photographs of dissected tissue, were astonishing. One entry, dated May 2, 1938, reads, "He was achieving tumor regression rates that mainstream science would not see for another 40 years. He was on the brink of a cure." Convinced he had a breakthrough that could save millions of lives, Volkov knew he could not proceed alone. He needed collaboration, resources, and clinical trials, all things that required the backing of a major institution. Swallowing his pride, he compiled his 5 years of research into a comprehensive proposal and once again approached Harvard, not Finch's department, but the university's central administration. He hoped that the sheer weight of his evidence, the undeniable potential of his findings, would overcome the prejudice that had thwarted him before. He was tragically mistaken. The response was faster this time and far more brutal. He was summoned to a meeting not with scientists but with administrators. The tone was not one of academic inquiry but of interrogation. They questioned his methods, his credentials, the very legitimacy of his private research. The verdict was delivered in a stark, chilling directive. He was to cease all unapproved foreign research immediately. The word foreign was no accident. It was a brand, a mark of suspicion. The late 1930s were a time of rising nationalism and intense xenophobia. War was brewing in Europe, and anything or anyone that deviated from the established American norm was seen as a potential threat. Volkov's work wasn't just unconventional. In their eyes, it was dangerously alien. The final nail in the coffin was an internal memo uncovered in the 2000s through a Freedom of Information Act request. Dated March 1940 and circulated among the university's top brass, it explicitly warned all departments against they weren't just rejecting his science, they were actively blocking it, strangling a potential cure in its cradle out of fear and bigotry. They cut off his access to university libraries, barred him from consulting with faculty, and discreetly warned chemical suppliers against doing business with him. The system wasn't just ignoring him anymore, it was hunting him. What systemic fear, what institutional xenophobia drove such a catastrophic dismissal of potential life-saving knowledge? The fear, it turned out, was not of scientific failure, but of a paradigm-shifting success that came from the wrong kind of person. The chilling silence surrounding Dr. Volkov's cancer research was not a passive oversight. It was an active, strategic suppression that reverberated through decades of medical history. Volkov, defeated and professionally isolated, eventually faded into obscurity, taking a low-level teaching position at a small community college and dying of a heart attack in 1952, a forgotten man. Meanwhile, the world moved on. The role of adenosine triphosphate became a cornerstone of biochemistry, taught in every high school biology class and every university textbook on the planet. Yet, for nearly 70 years, the credit for its discovery was primarily attributed to Karl Lohmann, a German scientist who independently identified it a year after Volkov, and to Dr. Alastair Finch, whose sanitized, plagiarized paper had cemented his own name in the official record. Volkov's name was a ghost, a footnote to a footnote, his foundational contribution almost completely lost. His revolutionary cancer research vanished entirely, its notebooks gathering dust in an attic, a silent testament to a future that never was. The inertia of accepted history is a powerful force, and the official narrative, once set, is incredibly difficult to change. It wasn't until the late 1990s that the first cracks in this historical edifice appeared. A small, dedicated group of historians of science at Johns Hopkins, focused on uncovering suppressed research, stumbled upon a reference to Volkov in the private correspondence of another, more famous scientist. Intrigued by the cryptic mention of a brilliant but sidelined Russian at Harvard, they began to dig. This was before widespread digitization. It was a painstaking process of sifting through physical archives, cross-referencing shipping manifests for laboratory equipment, and filing formal requests for university records. Their breakthrough came when they located Volkov's grandniece, who had kept the trunk containing his private lab notebooks. The discovery of these notebooks was the equivalent of finding a lost Dead Sea Scroll of science. Their independent historical analyses, published in a series of papers starting in 2003, sent shockwaves through the academic community. They meticulously laid out the timeline, comparing the dates on Volkov's ATP research with Finch's publication. They forensically deconstructed his cancer experiments, demonstrating their rigor and their staggering prescience. For the first time, the full scope of the injustice became clear. The declassified university memo from 1940, released years later, was the smoking gun, corroborating their entire thesis. It exposed a systematic, top-down campaign of marginalization rooted not in scientific disagreement, but in raw, undisguised xenophobia. The impact of this reclamation is staggering and deeply sobering. We can now draw a direct line from Volkov's suppressed work in the 1930s to the cutting edge of 21st-century cancer therapy. Today, a whole class of drugs known as metabolic inhibitors works on the very principle Volkov pioneered, starving cancer cells by blocking their unique energy pathways. The 2019 Nobel Prize in Physiology or Medicine was awarded for discoveries of how cells sense and adapt to oxygen availability, a field inextricably linked to the metabolic differences between healthy and cancerous cells that Volkov was exploring 80 years prior. The question is unavoidable and haunting. How much faster could we have gotten here? How many millions of lives were lost or diminished in the intervening decades because one institution in one moment chose prejudice over progress? The delay was not a footnote in history. It was a generational tragedy measured in human suffering. His story is a devastating reminder that scientific progress is not an inevitable linear march toward truth. It is a human endeavor, susceptible to all our human failings, our biases, our fears, our jealousies, and our capacity for profound injustice. The system that erased Elias Volkov was not an anomaly. It is a system that still exists in subtler forms today. His legacy, now partially restored, forces us to ask the most critical question of all. How many other essential truths remain buried in forgotten notebooks? How many other cures are locked away in the minds of those we have silenced, simply because the discoverer didn't fit the mold or wasn't one of us?